Hello everyone. In the last class, we derived approximate formulae for the first and second derivative using Taylor series. Let's understand them better using some examples. In the first example is very simple. Let's see what is it. If f of x is equal to x cube, find f dash of 1. Okay. It's a very simple problem. But let's do this to understand the formula, approximate formula, finite difference formula. So we know f of x is x cube, so f dash of x will be 3x square, and then f dash of 1 will be 3. Okay, so f dash of 1 is 3. This is the exact solution, the analytical solution. Let's use a forward difference formula to find f dash of x. Forward difference formula is given is given as f dash of x is equal to f of x plus delta x minus f of x over delta x. Okay, this delta x is our choice. If in this For doing this problem, let's take delta x as 0.1, but smaller the value of delta x, more accurate is your solution. Okay, so delta x is our choice for this problem. I'll take delta x as 0.1. Even you can take a more smaller value to get more accurate solution, like delta x is equal to 0.01 or 0.001. It's your choice. Okay, so f dash of 1 will become uh, so here see, I need to find f dash of 1. Okay, I need to find in the problem f dash of 1. So x is my 1 now. Okay, so f dash of 1 will become f of 1 plus delta x is 0.1. So f of 1 plus 0.1 minus f of 1, because I want to find f of 1. Okay, in the problem I asked to find f of 1. So x is your 1 and delta x is your 0.1. Okay, so f of x is f of 1 over delta x is 0.1. So we'll get f of 1.1 minus f of 1 over 0.1. Okay, so f of x is x cube, so f of 1.1 is 1.1 the whole cube minus f of 1 is 1 cube over 0.1. So if you do this, you will get f of 1 as 3.31. Okay, so this is not the exact formula. I already said in the last lecture it is the approximate formula. Okay, but f dash of 1 is 3. So f dash of 1, using forward difference formula, I got f dash of 1 as 3.31. The error is 0. Absolute error is 0.31. Okay, that is 3 minus 3.31, modulus of 3 minus 3.31, you will get 0.31. Okay, to get more accurate solution, I suggest you to take the value of delta x to be more small. Okay, you can also use the backward difference formula. The backward difference formula for finding f dash of x is nothing but f of x minus f of x minus delta x over del x. So if you substitute the values, you'll get f of 1 minus f of 0.9 over 0.1. F of 1, you know, it's 1 cube minus f of 0.9 is 0.9 the whole cube. So if you substitute and if you calculate, you will get f dash of 1 as 2.71 using backward difference formula. The absolute error is 0.29. Okay, so backward difference formula is a bit more accurate than forward difference formula because the absolute error is reduced. And now we'll use a central difference formula. Okay, so in central using central difference formula, f dash of x is given by f of x plus delta x minus f of x minus delta x over 2 delta x. Okay, so f dash of 1, if you put the values of x and delta x, you will get f dash of 1 as f of 1.1 minus f of 0.9 over 0.2. F of 1.1 is 1.1 the whole cube minus f of 0.9 is 0.9 the whole cube. If you plug that values and if you calculate, you'll get f dash of 1 as 3.01. 3.01 is very close to 3. and the absolute error is 0.01. So we can conclude that, or we can bring a conclusion from this problem, that central difference formula is more accurate than backward difference formula and forward difference formula. Always remember, central difference formula is more accurate than backward and forward difference formula. So from now onwards, we'll be using only central difference approximate formulas for finding the derivatives. Another thing you should know is, smaller the value of delta x, more accurate is your solution. Okay, so this problem was a very simple problem. Okay, no need of putting all this formula. But if you get a transcendental function, a difficult function, a transcendental function like this, f of x is equal to x square e power x sin x. Okay, many often our engineering problems are very complex like this. Okay, finding a derivative for this functions is very difficult because you need to remember so many formulae. Okay, but using a numerical methods, it becomes very simple. Okay, so if f of, let's take one difficult problem. If f of x is equal to x square times e power x times sin x, find f dash of 2. Okay, so we know that central difference formula is more accurate than forward and backward difference formula, so I'll use only central difference formula. Central difference formula, for first derivative is given as f dash of x is equal to f of x plus del x minus f of x minus del x over 2 times of del x. Okay, so x is your 2 because you need to find f dash of 2, so x is your 2. Delta x is our choice, so I'm taking for this problem delta x as 0.1. So when I substitute x and delta x in this formula, I will get f dash of 2 as f of 2.1 minus f of 1.9 over 0.2. Okay, 2 times delta x, 2 times 0.1 is 0.2. Okay, f of 2.1, f of x is given by this expression, so f of 2.1 is 2.1 the whole square times e to the power of 2.1 sine of 2.1, remember this is in radians. Okay, minus 1.9 the whole square times e to the power 1.9 times sine of 1.9 over 0.2. So if you put these values, if you calculate all these values, you will get f dash of 2 as 29.15. So without the use of this approximate formula, if I ask you to find f dash of 2 using an analytical method, it is very difficult. But when we use approximate formula derived from Taylor's series, the finding derivatives becomes very simple.